We're continuing to look at graphing and graphing techniques. We're going to use transformations to help us graph. And so in this lecture today, our objectives are to graph functions using vertical and horizontal shifts. We're going to graph functions using compressions and stretches. And we're going to graph functions using reflections across the x-axis and the y-axis. So the following is kind of a summary of what we need to do in order to shift or translate our graph. And so let me just kind of read through this really quickly, and then we'll look at some examples. So each graphing technique has different effects on the graph of a function. We'll see compressions and stretches change the proportions of the graph, and reflections change the orientations, but it's not proportions. Vertical and horizontal shifts change the location of the graph, which changes its without changing its proportion or orientation. Okay. So first thing is vertical shifts. And so we can recognize that it's going to be a vertical shift if you see our parent function, which was those list of functions that I told you we'd looked at last week that we needed to be familiar with. If you see that parent function and then you have some addition or subtraction of some constant. Okay, so vertical shifts. If we have y equals f of x plus k, where our constant is greater than 0, this shifts the graph of f up k units. So all we're doing is we're adding k to the y value. So if xy was a point on our graph, let's just say f of x here. If we were going to look at f of x plus k, this is going to change our point on the graph. That's a k, which looks like an x. That's going to change our point on the graph. And it's changing the y value. So x is going to stay the same. All you're doing is you're adding k to that y value. If you subtract a constant, so y equals f of x minus k, again, k is greater than 0. So you're subtracting off a number. Shift the graph f down k units. So we're subtracting k from f of x. F of x, remember, is the same thing as saying y. So if it was a minus down here, we would subtract k from our y value. Okay, so adding the constant outside, that's affecting it vertical shift. If we add or subtract the constant inside, then it's going to be a horizontal shift. So y equals f x plus h, where h is greater than 0. This shifts the graph of f to the left h units. We replace x by x plus h. If we have y equals x minus h, or again, our h value is greater than 0, then this shifts the graph f to the right h units. Replace x by x minus h. Shrinking and compressing, or compressing and stretching, depends on the book, calls it different things. To me, sometimes it seems opposite of what they're talking about. So let's just look at this. So compressing and stretching. So if you have some constant times our y value, y equals a times f of x, again, we're going to say that our constant is bigger than 0, greater than 0. Then what we're doing is we're multiplying every y coordinate, y equals f of x, by a. And this stretches the graph vertically if a is bigger than 1. And it compresses the graph vertically if a is between 0 and 1. So for instance, if we had some graph here, let's say that this was f of x equals x squared. And if we had an a value, which was greater than 1, and we looked at a times f of x, this is going to stretch it. Is that what they call it? Yeah, so stretch it. It's going to grow at a faster rate. Y is getting bigger faster. X is staying the same. If our y or a value was between 0 and 1, and we multiply a times f of x, then we're multiplying that y value by a number between 0 and 1. So it's going to make it smaller. The y value is growing at a slower rate. So this compresses the graph of f vertically if a is between 0 and 1. So if we're looking at it and we're multiplying inside, not outside, so y equals f a times x, so f of ax, where a is bigger than 0. So if we multiply each x coordinate of y equals f of x by the reciprocal, 1 over a. So notice that when it's inside, it actually does what the opposite is than if it was outside. Same thing with our horizontal shifts. When we had added an h inside, this actually moved it to the left instead of the right. Where if we subtracted h inside, this moved it to the right h units. So going the opposite direction. Same thing here. If we multiply it inside, we're multiplying it by 1 over a, the reciprocal. Okay. So if a is between 0 and 1, this stretches the graph horizontally. If a is greater than 1, this is compressing the graph horizontally. And the last thing, and we've looked at this before when we were looking at and testing to see if things were symmetrical with the x-axis or y-axis, reflections. If you see that we have y equals negative f of x, this reflects it, changing the y value. So that's a reflection across the x-axis. And all we do is we're going to multiply our y value by -1. So we're just changing our y sign, and that would get us our new point. A reflection across the y-axis, that's inside, y equals negative, or f of negative x. And this reflects the graph of f about x on the y-axis. And we replace x by negative x. Okay, so I know that's a lot, and normally I would be writing that out, but I think that saving time and just reading through it and talking about it and then doing more examples might be more helpful for you guys. Okay, so I have you guys try it. We haven't even looked at doing one together, but maybe you guys have this. So multiple choice, and it's multiple choice. So which function has a graph that is the graph of y equals f of y equals the square root of x shifted down 3 units? Do you think it would be A, B, C, or D? Okay, so those of you that had answered D are correct. And so let's look at this. So when it is a vertical shift, it has to be outside of the, in this case, the square root. So for instance, if f of x is equal to the square root of x, and we wanted to shift it down 3 units, this means that I'm going to subtract 3 from it. But since it's shifting it vertically, that's affecting the y value. So think of it that we're adding or subtracting that from our y value, and f of x is our y value. So in this case, because we're going down, we're going to subtract 3. And so if you think about that, subtracting 3 from this function f of x, well, f of x, right, is the square root of x. And then if we subtract 3 from it, it looks like this, which is D. Where if we were going to shift it horizontally, that's where we add it inside. So let's say we wanted to shift y equals square root of x to the left 3 units. So if it's inside, and so that's affecting my x value, right? Going left and right affects the x on the coordinate system. And so if I looked at this, again, f of x equals the square root of x, it's affecting my x value. This is actually going to the left and right. When we're affecting the x, we actually do opposite of what we're thinking. So in this case, this is going to be, so left normally I think go to the negative, but it's opposite, so +3. And so if you think about this, you're going in and wherever you see an x in our original function f of x, we're going to replace that with that whole expression x + 3. So that piece would be underneath the radical. And so I have the square root, I see an x there, so replace it with this x + 3. So that would be underneath the radical.
So that moves it horizontally.
Yeah, and that moves it horizontally,
Okay.
and then the case to the left.
And then outside moves it vertically?
Yeah, exactly.
Okay. Okay, thank you.
You're welcome. Okay, so for the next example, let's write the function whose graph is of y equals x cubed, but has the following transformation. And so if it helps you, write y as f of x equals x cubed. And so if we're shifting, part A says, let's shift f of x to the right 4 units. So going to the right or left, again, is affecting the x value of my point. So that has to be inside here. And so if we're going to the right, we have to actually subtract off what we're going to. So in this case, this is going to be x - 4. And so we're going to go in, and wherever we see an x in our function of f of x, we're replacing it with x - 4. And so this is going to equal x - 4 quantity cubed. If we're going to shift it up 4 units, part B says shift that graph y equals x cubed up 4 units. If we're going up or down, that affects the y value of our point. Well, f of x is another way of saying y. And so we're going to add 4 outside of the function f of x. And so in this case, when we again have f of x equals x cubed and we add 4 outside, that's going to give us that x cubed and then the +4. If we want to reflect it across the y-axis. So again, I kind of think about this. If I'm going to reflect it across the y-axis, I think to myself, if I'm affecting my x value or my y value of my point, this is affecting the x value of my point. It's changing the sign for x. So a reflection across the y-axis, I'm going to put it inside. And this is going to be f of negative x. So go back to our original function, f of x equals x cubed, and wherever we see an x, we're going to replace that with a negative x. And so in this case, we have this is equal to negative x quantity cubed, which we can simplify. Negative x times negative x is positive x squared times another negative x. We could write that as negative x cubed. So part D, this asks us to look at our graph of y equals x cubed, but this time we want to vertically stretch by a factor of 5. Vertically stretch by a factor of 5. Okay, so if I'm vertically stretching it, I'm stretching it up. That means that my Y value are growing at a faster rate. And so if my Y values are growing at a faster rate, that means that I'm going to multiply my Y value by 5. And so I'm going to put this outside. So this would be 5 times my f of x value. Well, again, f of x is equal to x cubed. So this would be 5 times x cubed. And the last one, horizontally compressed by a factor of 1/2. So let's look at that one. So horizontally compressed by a factor of 1/2. So that's inside, it's affecting it horizontally. So that's our x. And so we're going to look at this as f of x is 1/2 times x. Okay, so another example. In this example, it says find the function that is finally graphed after each of the following transformations is applied to the graph of y equals the square root of x. And then it also says do this in the order that it's stated. So let's apply each one of these to our function. Let's look at what's happening to the graph in each case. And let's apply each transformation to our new function that we're getting. So if we have y equals f of x, or y equals the square root of x, which I'm going to call it f of x. So f of x equals the square root of x. And first thing that we want to do is we want to reflect this across the x-axis. So we're reflecting this across the x-axis. Again, look at what's happening. Is this affecting the x or the y value? Well, if we're taking a point and reflect it across the x-axis, that's changing the sign of my y value. F of x is the same thing as y. And so changing the sign of y, we would have to look at negative outside of f of x. And so this would give us negative square root of x. Well, let's first look at what y or f of x equals the square root of x looks like. So our original function looks like this, that general shape. If we reflect this across the x-axis, we now get the graph that looks like this. And so the next thing we want to do is we want to take this graph y equals negative f of x, and we now want to shift it to the right 3 units. So I'm going to take my new function. Maybe we can call it g of x equals negative square root of x. And if we want to move this to the right, I'm sorry, move to the right 3 units. Okay, so moving to the right 3 units, that's affecting my x value. When we're doing that to our x value, though, we're going to go in here and instead we do the opposite. So think of it as subtracting 3 instead. And so going to the right 3 units, we have x minus 3. So going in and plugging in x minus 3 into our g of x, this gives me negative the square root of x minus 3. So we're taking this graph and we're shifting it to the right 3 units. So before, this point was at the origin. Now it's going to be at 3, 0. So it's going to look like this. So this is our graph, y equals negative square root of x minus 3. And then the last thing we want to do is we want to shift this down 2 units. So let's maybe call that last function we just found h of x. So if we let h of x equal this negative square root of x minus 3, and we want to go down 2 units. So if it's going down, we're affecting our y value. And so we're going to subtract 2 from our y value, which is in this case h of x. So if we subtract 2 from that, we have our original function h of x, which is this negative square root of x minus 3 under the radical. And outside of the radical, we have this minus 2. So all we're doing is we're looking at that last graph we looked at, and we're shifting it down 2 units. And so the starting point now that was at 3, 0 is now going to be at 3, negative 2. So it looks like this. Okay. So with that, we've done in the order that it told us, and we came up with the equations and graphs of our new functions. So you can always go after you've done this, because you need to be able to do this by yourself. You can always go and check your work on Desmos, or if you have a graphing calculator, you can use that. But Desmos.com has a graphing calculator feature. So let me pull that up and let's look at what we just did and show it on the graph. Okay, so I pulled up the program and we're going to define our first function, which was y equals the square root of x. So I'm going to just type sqrt and it's going to make that square root symbol. So that was our original function. It then told us to graph that. It wanted to bring that reflection across the x-axis. And so we changed the sign outside, and so that would be negative square root x. We then took that function, I'll turn this one off for now. Oops, I didn't mean to turn it off. Oh well. I'm going to now take that function and I'm going to, we shifted it to the right 3 units. So this is negative square root, and then we did x minus 3. So now what we had in blue is shifted to the right 3 units. And then we took that and we shifted it down 2 units. So this was negative square root, we said, x minus 3. Outside would be minus 2. Which is the exact same thing we had gotten before when we did it by hand. Okay, so let me see if there's any questions and then we'll look at another one. Okay, so the next example in front of us says if the point 3, 6 is on the graph y equals f of x, which of the following point must be on the graph of y equals f of negative x? So I'm gonna let you guys think about it for a second and put the answer in the chat if you're in class right now, but don't push enter until I tell you to. So awesome. You guys got that one. All you're doing, you're multiplying your x value by -1. So if we multiply our x value, which is 3 here, by -1, that is going to get us -3. Our y value staying the same of 6. So -3, 6 would be our point. So in the following example, we're given the graph of f of x. And we want to now graph h of x, which is this graph of f of x, but f of x plus 1 inside the parentheses, and outside the parentheses, we have a -2. So looking at this plus 1, it's inside, it's affecting my x value. So this shifts the graph to the left one. This -2 outside, this is affecting the y value, so this shifts it down 2. So let's think about our new points. So if we had xy on our graph of f of x, what would our new points be on our graph of h of x? Well, if we are going to the left one, that means I have to subtract 1 from my x value. And I am going up, or not up, down 2. So I'm going to subtract 2 from my y value. So let's look at some points here. So that point -4, -2. Well, if we move this to the left one, that's what it said, right? Left one. Plus 1 is the left one. So I'm going to subtract 1 from my x value. So that's going to be -4 -1, comma, and we're subtracting 2 from my y value. So my y value in this case is -2, and then I'm going to subtract 2. So my new point here is -5, -4. So if I go over, I'm going to go -5 and down, so -4. So my new point here at -2, -2. Well, if I subtract 1 from my -2, I'm going to get a -3. And if I subtract 2 from my -2, I have a -4. So from -3, -4. And it's horizontal line there. And I can see that from above that this piece is going to be horizontal. So let's look at our other point that given, which is 2, 2. So this point 2, 2. If we subtract 1 from our x value, that gives us now 1. And if we subtract 2 from our y value, we're now at the point 1, 0. So this line in here with a transformation looks like this. And then the last one that we have given is 4, -2. So if we look at 4, -2 and look at our transformations of our graph, so 4 - 1, shifting it down 1, that's now going to become 3. And then I'm not shifting it down 1, shifting it to the right one. Left one, I mean. And then down 2. So -2, -2. So this is going to get me a 0.3 - 4. Which is right here. So looking at this, we just graphed the given graph of f of x using our transformations. So we have a graph of f of x in front of us, and it's asking us to graph q of x equals 1/2 times f of x. And so the 1/2 is outside, that's affecting my y value. And so I can think about points on my function f of x, and I can pull out ones that are given to me. And I can look at what's happening to get my points on q of x. Well, again, it's affecting my y value. And so my point xy from f of x is now going to become x, comma, 1/2 times y. So choosing points, if we had a point here, which was at -π0, and we multiply our y value by 1/2 and keep the x value the same, I have -π, but 1/2 times 0 is still 0. Okay, so that point is going to stay there and it's not changing. This point here, which is -π/2, comma, -1. So again, I'm multiplying my y value by 1/2. And so 1/2 times -1 gives me -1/2. So now my point is going to be new and it's going to become -π/2 -1/2. So it comes down in here. And it's kind of curved, but that doesn't look too curved. Okay. My point 0, 0 in here. Well, multiplying my y value by 1/2 doesn't change that y sign and x stays the same. So I still get that point 0, 0. So it comes up here. This point in here, which was π/2 1, multiplying my y value by 1/2, x stays the same, I get π/2 1/2, which is here. And then the last point, which was at π0, multiplying my y value by 1/2 doesn't change it. 0 times 1/2 is 0. So I stay down here. So we get our new graph. Is the following. Of q of x. Okay, so we're coming back from break, but I did say I'd come back and I was questioning this one problem and I was off. So I had mentioned before, if we are doing something to our x value inside the function, it was opposite. And so if we want to horizontally compress by a factor of 1/2, we're multiplying instead of 1/2 to our x value, we're multiplying this by 2. So this should have been y f of 2 of x. And so if we did it that way, and we go in here, oops, and I didn't even finish. And we plug in 2x wherever we saw an x in our function of f of x, we would have this 2x quantity cubed, which is 8x cubed. Okay, so we have another example in front of us. It says, suppose that the function y equals f of x is decreasing on an interval from -2 to 7. Over what interval is the graph y equals f of x plus 2 decreasing? Is what it's asking for part A. Okay, let's look at this. So let's just draw a picture of a graph that is decreasing from -2 to 7 on that interval. So if I look at this, and it could look like anything, except it just has to be decreasing. I just want to get a visual. So if it's going down from x equals -2 to 7, so maybe it looks something like this, right? Okay, so there's decreasing from x equals -2 to 7. And we want to know from there over what integral is the graph y equals f of x plus 2 decreasing. Well, let's think about what that x plus 2 inside the parentheses is doing. It's inside the parentheses, so it's affecting my x value. Kind of think of it opposite. So this moves it the left 2 units. So if I'm moving my whole function to the left 2 units, then it's not starting to decrease at -2. It would be starting to decrease at -4. So if that's the case, then the interval where it's decreasing, it's going to start at -4, and then it's going to stop. It stopped at 7 before, but moving it to the left 2 units, that means it's going to stop at 5. Okay, so the next question says, looking at, again, decreasing from -2 to 7, what interval would the graph of y equals f of x minus 5 be decreasing? Well, that -5 is inside. So this tells me this moves the graph to the right. Five units. So if I'm moving my graph to the right 5 units and I'm starting at -2, well, -2 plus 5, so this is going to start at 3. And stopping at 7 before, but if I move it to the right 5, 7 plus 5, that's 12. So the graph will be decreasing on the interval 3, 12. Part C says, is the graph y equals -f of x increasing or decreasing, or neither, on the interval -2, 7. Okay, well, let's see what's happening. That negative in front of the f of x, that's changing my y value. So if we change our y value, that's telling me that I'm having a reflection across the x-axis. So if I'm changing my y value and reflect what I have here across the x-axis, that would be giving me something that looked like this. Let's do it in this color. right? So this right here would be negative f of x. And so if I look at it, saying that start at -2 and going to 7, my graph is now increasing. On the interval from -2 to 7. Okay. And part D says, is the graph of y equals f of -x increasing or decreasing, or neither on the interval -7, 2? Okay, so the negative inside this is a reflection across the y-axis. So if I looked at this and I reflected what I had, whoops. Maybe. If I looked at what I had, right, it was just going down from -2 to 7. And I reflect what I have right here across the y-axis. So this point here that was at -2 something is now going to be at 2 something. This is going to stay at the same spot. And my point here that was at 7, 0 across the y-axis is now going to become -7, 0. And so looking at that, this here would be my negative f of x. And so looking at it from -7, 2, my graph is increasing. Let me see if there's any questions. So we have g of x here is equal to 2 times the absolute value of 1 minus x. In the directions, it says graph each function using the techniques of shifting, compressing, stretching, and or reflecting. Start with a graph of the basic function. So looking at this, let's figure out what the parent function is. And show all the steps. Be sure to show at least 3 key points. Find the domain and the range of each function. Okay. So first thing, let's determine what the parent function is. What are we doing transformations to? So looking at this, I see the absolute value. And so let's call it f of x. So let's call f of x the parent function. And the parent function I can see in here is just the absolute value of x. So if I plotted points, and I really shouldn't have to, I should know what the general shape is, which is a V. If I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in -1, I get 1. 2, I get 2. -2, 2. So we have this V. So part B, let's look at the transformations that are going on. I'm going to rewrite my g of x a little bit, and I think that's going to help us see a little more. And so g of x, another way that I can rewrite this is 2 absolute value. I'm going to rewrite it as -x plus 1 instead of 1 minus x. So I see that this negative is in front of my x value. And so this looks like, just in this case, if I had f of x was the absolute value of x, to get that negative there, I would look at f of negative x. So changing my sign on x, I know that this is a reflection across the y-axis. Well, if I took what I had and I reflect this across the y-axis, it's just going to be the exact same thing that I had before. This +1 in here, this is shifting the graph to the left 1 unit. So now I have this f of negative x +1 . So if I take this and I shift it to the left 1 unit, this point right here that was at 0, 0 is now at -1, 0. This point here that was at 1, 1 is now at 0, 1. This point here that was at -1, 1 is now at -2, 1. So that's what we get in the green. And then we have this 2 that is outside. So let's graph that piece. At 2, this is changing the sign of my y value, not the sign, but the value of y. So this is multiplying y by 2. So if I think about my point here at -1, 0, and I multiply my y value by 2, well, 0 times 2 doesn't affect anything. Where in this case, when I was at the point now at 0, 1, and I multiply my y value by 2, I now get 0, 2. This point here, if I multiply my y value, which was 1, by 2, I get the point -2, 2. And so we get this graph that looks like this. And so this is our final function of g of x. And so if I look at the domain and the range, doing any of these transformations didn't affect my domain. My domain is all real numbers. My range, if I look at it, my range actually didn't change either. My range of my original function, absolute value of x, the parent function is from 0 to infinity. And if I look at the range here, it's also from 0 to infinity. So that is the last section we're covering in our book, chapter 3, which is 3.5.